We are now going to begin our next little hands-on exercise. And this hands-on exercise is going to build on some of the skills we just built up, but extend them. It's going to extend them conceptually with some deepened discussion of some of the mechanisms we use. And second of all, it's going to add new elements into our repertoire. Yes, Larissa. Not yet, because it's not ready for it yet, but shortly. Yeah. Give me a minute and we'll get going here. Okay, so this morning we had spoken about state charts, and state charts in brief simultaneously characterized elements of a person's state, the actions that can change that state, and the rules that govern those actions, that in other words, that dictate whether or not someone is changes state at any one time. And we're going to try building up a model which has some state charts in a simple way. Okay, and this model is going to allow us to see how to define state charts and how to distribute people among those states for their initial state, as well as how to have them transition under certain rules or governed by certain rules here. Okay, so in order to do this, I'd like you to go to AnyLogic and go and close out the model that we have been building up. Okay, and we're going to start adding a new state chart here to illustrate this. And I'm going to need to double check the specific model that I'm going to be creating with you. So here we go, and right, great. Okay. So this doesn't have a model currently assigned, so we'll just have to pick one of these. Great. Okay, so give me a moment and good. Excellent. Okay, so we're going to build a model associated with smoking and use it to illustrate tobacco use. Okay. Yes, question. Yeah, I haven't started with in AnyLogic. I'm just describing the context. Thank you. So we're going to be building up a model showing people's progression over stages of tobacco use. And as time allows, we may further represent how that affects other health issues captured in other state charts. Okay. With that guide point in mind, I'm going to now close out my model and start screen sharing here. Okay. So we'll be closing out this past model that we built, and we're going to start a new model. Okay. What I'm going to do is go File, New, and Model. And we're going to create a model that's called Tobacco Use Simple. Okay. Use Simple. And I'm going to choose a time frame for this model that's in years. Okay. And because I'm going to be reasoning, not because it's anything to do with the time step, no, but it just some of the statistics we'll be talking about will be on a yearly basis. Okay. so here we're going to now go and build this up. So the first thing we want to do is add in a person. We want to start with a model that is empty and add in a person into it to describe a theory of personhood. So does anyone remember how you do this? Exactly, yeah. So we right click on the model as a whole and we say agent type and we say person, okay? And that creates our basic representation of person. Now, as I said, it's often convenient to give them a visual representation at this point. I'm actually doing so deliberately because there's a bit of extra work if you only add that in later. If you add it in from the start, you can sidestep some issues when you change their appearance to tell any logic about it. So I'm going to go and I think we'll again give them a similar representation as last time. So we're going to go to this presentation palette and we're going to add in an oval, and that oval will be sized to not be too large, okay? So this should be skills that are familiar to you. And having done so, we're going to add in a population of people. Can anyone remind me, how do we add in a population of people? Anyone? How do we add in a population here of people? Where do we add it? Into Maine. Yeah, so it's going to live in Maine. Is exactly it. And we're going to need to indicate that we want to create such a model. We're going to need to drag person into Maine or such a population. So go to Maine and go to projects, and we drag in person to Maine. There we go. And we should call it population. Okay. And this is a population of agents. Okay. Okay, so we have a population. Notice that I dragged it in, I let it go, and then I changed this to population of agents. Do you remember that? Okay, now, if we were to, we should be able to build this model, and we should be able to run it, right? So again, raise your hand if you need help here, right? Okay, so we should be able to run it, and if we run it, we will see a population of what size? Anyone? 100, yeah, and it's because it's original size. Now, I'm going to show you something that will expand your awareness of where parameters can be used. You'll notice that before we used agent parameters. And I said this morning that parameters in any logic serve two functions. Number one, they encode assumptions. Number two, they communicate those assumptions from the point of creation to the to where it's needed. So if there's a parameter in an agent, where is it that that assumption was specified? Does anyone remember? If we had a parameter in person, where was that specified? The value of that to assume for that. Anyone remember? Yeah, it was in person, exactly. But I'm sorry, but it was, be careful. The parameter was specified in person. So there was a, for example, an age parameter in person. But where was the, sorry, the parameter itself was specified in person. Where was the value for it specified? The value to assume. It was in population. It was specific to the population. Each population could draw it from a different distribution. Okay, so that's where the person is created. That's the thing that creates the person. For the population that starts in the model, that's where it's created. As we'll see, when people come into the model, we say birth or immigration, we'll actually have it created elsewhere. But for those who start in the population, it's in the population. Okay. Those who start already created. Okay, so what I'd like to do now is to go and add in a parameter in a different place. Instead of adding it to agent, I want to add it to main. Okay. So we're going to go to main and we're going to add a parameter to main. And this parameter is going to be called population size. Okay. This too will encode an assumption. This too will serve to communicate an assumption from the point of creation to the thing being created, which has this parameter, namely main. The population size, how did I do that? I went to main, I went to the palette, I went down to this agent palette, and I dragged in a parameter into here. And I called it population size with a capital S, okay? This population size is not a continuous value. It's not a double. It is instead an integer, 0 or 1 or 2 or 3. It's not 23.25. Within agent-based models, we have a quantized population. What I mean by that is we can't have partial people in there. This is in contrast to aggregate models where we commonly will deal with the model. We may say, oh, it's a 32.56 population, and we sort of are willing to forgive it for this and just say the population is going up or down. Maybe we view it probabilistically. But in an agent-based model, at any one time, there's a certain number, a count of people, and it's 0, 1, 2, 3, 4, etc. This actually matters. We have a published paper on, for example, antimicrobial resistance, looking at the results of a very thoughtful model done by a close colleague of mine, which looks at drug-resistant gonorrhea. And using a set of model assumptions, it shows something rather provocative. It shows that focusing on a subset of the population with highest levels of risk behavior for gonorrhea, while it might be useful for fighting gonorrhea, that model would suggest that it actually is something which, if you try to intervene in that high-risk group preferentially, you may worsen drug resistance. The provocative result. It's saying you may think that you are achieving high leverage gains by focusing on that subgroup. But in fact, when it comes to drug resistance, you're putting yourself backwards. You're making the situation worse by focusing on it. Provocative is nothing else. And we re-implemented that model in an agent-based framework. And it had more detail. A network, for example, for people to interact, etc. And a more detailed description. And the phenomena disappeared. The infection would die out. The drug-resistant infection would die out for a while. It wouldn't bounce back because 0 people had the infection. It wasn't that there was 0.0001 of the population with the infection and it persisted in that. And so we started tearing away the assumptions of the model. Eventually, we ended up implementing a model just like theirs, but it was restricted. It was a compartmental model there. We had done it with an agent-based model, but we ended up, to show the point, doing it to a compartmental model where if it went below 1 person, it was considered extinct, or below 0.5 person, it's considered totally extinct. And it turns out their conclusion disappeared entirely because their conclusion relied on drug resistance surviving even if you had the tiniest fraction of the person that had it, like 10 to the -6 person. And that's what it relied on in order to lead to the subsequent rebound. It would go to very, very, very low levels, and then as the night follows the day, it would inexorably grow into more and more drug resistance. And what we found is actually, you want to drive it extinct, you want to drive drug resistance extinct, focusing on that population engaged in high-risk activity is exactly what you want to do. And it does not persist in this kind of weird inchoate way and someone fingernail something like that. Particularly, I might add for gonorrhea. This was those quantization assumptions can actually make a real difference. They may seem innocuous at one level, but they are in fact fairly substantive in their implications. So here we have a population size, it's an integer, and its default value will be 100. After all, that's what we're replacing. Now we want a population whose size is given by population size. Where would we go for that? Can anyone riddle me that? Where might we go? We wanted a population whose population size is given by that parameter. Where will we specify the size of the actual population that's created in the model? Anyone? And population, indeed. Well spoken. So let's go take a look at that. So let's go over to population itself. And notice it says 100 right here. What do we need to change that to? Population size, indeed. So we say population size. Okay. Now, I'm finessing this a little bit because if I were persnickety in Java, and if you want to head off some problems later, some misunderstandings, you could say my population size of me. And I could say this dot population size. That's main's population size, but I'm not going to get into that. Okay, we'll leave that for a later time. But it's based on the population size. So let's try this. So now we're saying this population is the size of the population is given by the value of this parameter. You may say, what's the good of that? It's 100. It's 100. What's the difference? Because we specified as a parameter, we can do what? We can change it. Where can we change it? Well, we change it where it's the point of creation. Remember, by making age a parameter for an agent, we could specify in the population different assumptions about it, derived from a distribution. Here, where do we specify the value of a parameter that's in main? We specify it in the experiment. It's going to be important later when we talk about sensitivity analysis or calibration. We'll specify the values of the parameters for the model to assume in the experiment. There, we're going to be tuning them to best match the data from the world. We're going to be adjusting them to find where it's most sensitive. Here, all we want is scenarios that posit different population sizes. So the first one, I'm just going to use the population size of 100. I'll run it. Remember, run early, run often. Build early, build often. So I'm going to run it. And here we go. And it's running. And lo and behold, there's a population size of 100. Look at that, 100 agents in the population. They stand arrayed before us, ladies and gentlemen. Now let's create another scenario. There's two ways we can create scenarios. We can go say new experiment. That's one way. It's often a pretty good way. And for now, it will suffice. But I'll tell you a more savvy way. If you have experiments which have a lot of parameters anyway, and you want to use those, but you want to change one of them, you want to retain the others, you can right-click on this and say copy. And then you can right-click on this and say paste. And that will copy paste. It'll copy all the assumptions, and then you can change the one of your wishing. So I'm going to say big population, not very imaginative, but effective, communicative. And I'm going to say it's a population size of 1,000. How did I do that? What did I do? I right-clicked on this, and then I clicked on this, and I did paste, and it came, and it's called simulation 1, and I said build. I called it big population instead, and I filled in its population size of 1,000. You'll notice it's in bold. It indicates bold because I have boldly given something other than the default value. If I give the default value of 100, it turns out it will be a happy camper. Well, it's unhappy or happier, but you notice it doesn't bold it because that's the default value. If it's bold, it indicates you changed from the default, and that's good to know about sometimes. So I called it a big population. Let's go try it. There we go. Right click, run, and lo and behold, population size 1,000. There we are, 1,000 agents. They lie in front of us. Okay, there we go. Okay, so ladies and gentlemen, we've used a parameter to specify a assumption for the model. And then in experiments, we specify the value of that parameter. And the parameter communicates that value to main. So when it comes time for main to create the population, it knows what the population is. Population size, the value for it is specified by these experiments. That's what's going on. Any question on that? We're going to use that a lot going forward. It's very useful. And in fact, the truth is many of our parameters we end up specifying in main just so we can have experiments, scenarios that alter those assumptions. That's where we have a lot of our assumptions about the model as a whole live in main. We capture those parameters. Okay. And later, we will see how in sensitivity analysis we can alter those assumptions and test the sensitivity. We can see in calibration how we adjust this. We can see in approximate Bayesian computation how we can test the model with different values of parameters. Okay, so important part of our repertoire. Let's now, though, get to the task at hand. Shall we not? Okay, with your leave, then I am going to go add some dynamic behavior to this puzzle. Oh, maybe we'll do one more thing. We're going to spread people around in space. Does anyone remember how we could specify their location in space? Does anyone remember that? Where do we specify their location? Indeed, we could specify it in main. And turns out we could specify it in the population, or we could specify it in another part of main if it's a bog simple standard one. We're going to go to main. We're going to go down main. And by clicking on it, make sure it's in properties. We're going to go to space and network. And here I'm going to say layout type random. Boom. Just like that. We're going to lay it out random. We could have said arranged, and arranged would have laid them out kind of in a grid. Okay. So let's go run that. I'm going to say, I said random, and I'm going to run the regular default. I'm going to the baseline scenario simulation. Boom. Here they are. They're spread out in space. What did I do to get that? I went to main. I viewed it in properties. I went down to space and networks, and I chose random here. Who needs TA help? The TAs sit, eager to help. Who would like help? Okay. Not right now. Their hope will be sought later, I think. Okay. So ladies and gentlemen, I set it to random, and that's what we saw. If we were to run the big population, we could do so with alacrity, and you'd see a fuller space there, more fulsome space, I should say. If you want, you could explore these more. For example, there's arranged here. There we go. And I'm going to specify this. And here we're laying them out in an arranged area, but I'm going to leave it as random. Yeah, if I may. Okay, so I'm going to say random. Okay, so I've shown you two different ways to lay agents out. One is through main. I can specify their locations. If it's kind of a simple rule, like lay them out uniformly, I can say so here. The other place I specified is, does anyone remember? Trying to build your muscle memory here. Where else was it? In population. Remember that whole thing where it could set their initial location? I set it by self.age in time immemorial. Do you remember that? 3 hours thence or something? Yeah, so that's the other place I could specify. But for now, we'll live with the one that I just did. Okay. So we did it in main. Often that's convenient. Okay. Now let's do the state chart. Okay. So let us put in some behavior for these agents. These agents right now, and even the model we built earlier, though it had heterogeneity, agents were static quantities. They didn't evolve over time. We wish to give them an evolving state. We're going to do it with state charts. So if we want state charts to be part of the theory of personhood, where do they need to live? In person is right. They need to live in person. So let us place them there as is their due in life. So here we go. We're going to go to person. Should have said as is their due or as is their lot in life. Sorry, that didn't come out quite well. Okay, so I'm going to person, and we're going to add to our theory of person. We could add age and all that sort of jazz, but let's focus on the task at hand. So I'm going to go to palette, and I'm going to go to the agent palette. This is depicted like Da Vinci's measure of man as a person with outstretched arms there in red. Do you see that? Yeah. I'd like you to click on that, and then we're going to draw a state chart. So the first part of drawing a state chart, or Lewis Carroll once said, and in Alice in Wonderland, I think, you start at the beginning, go to the end, and then stop. So we're going to start at the beginning, which is the state chart entry point. Okay, here we go. So this is going to be called smoking state chart. Okay. Notice it's all one word, presenting logic and Java, more generally, won't take spaces here. Okay, it's no space between them. I put it in camel case. You could put it in underbar if you want to. Notice I said state chart just because if someone sees the name, they'll know immediately, oh, it's a state chart. I'd rather like doing that. My students may not like doing that. That's okay. Okay. So what I'm going to do is I'm going to now add in possible states. What might be some possible states a person could be in with respect to smoking? Can anyone? Oh, question. Yes, Maya. Oh, that's sweet. Ah. Oh, that's horrendous. Okay. Thank you. I think Larissa's trying to get the cavalry here, but I actually am not sure what in the world has gone on. So pardon me, I'm just going to probe this for a moment, and just so there's no sign of life over there. I was working yesterday, and maybe someone could try just seeing if there's a power, any indication of power. Okay. The cavalry has arrived. Okay, so yeah, I will continue my narrative while going. So what are the possible states someone could be in with respect to smoking? Anyone? Non-smoker, a current smoker, and former smoker. Good, excellent. So we're going to add these in, and for the moment, and I emphasize that, we're going to add in people to start in the never smoker state, which has a certain sense to it, since people are born non-smokers. And then we're going to have some logic for their progression. So here we go. We're going to add in a never smoker state. Notice I like to name states with a capital here. You see that? And I think for those in the back, I think I'm going to try to make this larger. Let's see what we can do. Boom. Is that okay? Okay. Question over there? Oh, okay. So there we go. Okay. Now let's add in another state. What state might someone go to from a never smoker state? There's a logic here. Yeah, current smoker. They're not able to go from a never smoker state to a former smoker. That wouldn't make sense, right? To become a former smoker, you have to have at least 1 point smoke, right? So there's current smoker. There's a structure here to this. And now we can add in a former smoker. Can we not? Yeah, former smoker. Okay. Good. So now we have three states. That's good. But you notice it's not yet ready. It's not yet happy. And you'll notice down at the bottom, there's a worrisome sign. It's a 2 errors. Do you see that? And you should keep your eyes peeled for things like that in any logic. You could click on them and it'll show you a window here. And it'll say element is not reachable. Does anyone want to try to help interpret that? What is it saying by that? What is that meaning to us? Exactly. You can't get there from here, right? You can't get to current from the beginning of this. You can come in here. This is the entry point, but you can't get to current smoker, nor can you get to former smoker. So what do we need to add? Transitions, indeed. And so give me the directionality of that transitions. Again, there's structure here. Where can you go? From where to where? Good, 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 good. Can you go the other way? No, you can't. It doesn't make sense. There's an orderliness to this. I'm going to drag this. Now, this is the first time we dragged the transition, and I was a bit glib in how I showed that. So I'm going to drag it again and drag it over. And you'll notice as I'm doing this, there's some subtle things going on here. First thing is you'll notice it kind of has this stickiness to it. Like I can move it up and down and it kind of likes to stick. But more significant, you notice it's green there. Do you see that? That means it's actually connected. If it ain't green, it ain't good. Okay, green is the color state charts of the game. And so you could see a green there. Oh, gone. Any logic does have an undo key, by the way. And I want to connect it on both sides with green. If it's just close with white, it's no good. Okay, so you want to make it green on both sides. Is that okay? Okay. So now we have a transition from never smoker to current smoker. We'll come back about the rules, but this is saying there's an action that changes someone's state from being a never smoker to a current smoker. Fair enough. We'll come back to what the rule is in a few minutes. Now, how about going between current smoker and former smoker? What transition should there be there? Can anyone tell? Current to former is darn right. Exactly. Okay. So someone could be a former smoker and become a current smoker. Okay. Notice you can kind of prop these around and place them where you like. You can also double click on them and like stretch them to your heart's content. Okay. But these ones don't have to be stretched to be aesthetically pleasant. But often you'll end up stretching them by double clicking, adding handles, and moving them around. Okay. So here, ladies and gentlemen, we've added a state chart. Can we see what happens if we run it? What do you think will happen? Okay. Okay. So possibly nothing. Let's go run. Remember, build is your friend. It says build completed successfully. If you don't have these connected, it may cry out. So if you did it now, oh no, it looks, it's happy, but when you say build, it's happy, but it says error down at the bottom. Wade knows about these things. Sometimes you say build and it says no problem, ma'am, but it actually says problem. And it just says it down here, hanging transition. So we want to connect it up. Okay. By the way, you can double click on these handles after they're there and get rid of them. Okay, here we go. So let's run it. I'm gonna go run it. Here we go. There it is. So how can I see where people are? What sort of state? Guess what? I can go like this and I can drill down. And there, stand before me, people. And where are those people? Where's this person right now? You want to hazard a guess? What state are they in? Okay, yeah, we're in the red state here. And in fact, it will show in blue what's the next transition that's going to fire, absent some unexpected thing happening, like a message being sent. And I think red shows how they got into the current state, the red transition. And it's going back and forth. Why are they going back and forth like that in heinous sort of synchrony or heinous progression? Well, because they can, it's true. But it's not only because they can, it's because they must. So we'll come to this point in just a second, but it has to do with the logic of these transitions. But first, instead of drilling down, let's make it a bit more visual, can we not? Let's build our muscles, build these exercises you pursued earlier, these key lessons. Ready? Okay, so we're going to change their colors. What I want to do is I want to make Never Smoker green. And by the way, it's a good practice to sort of align their runtime colors that they assume as agents when you're running it with the colors in the diagram. So you know, oh, green means this, and this thing means this. It like changing this to green won't change anything at runtime. They'll look the same. It won't change anything when you're running the model, in other words. But it does clue you in that green means never smoker. Let's make current smoker red, and let's make former smoker gray. Okay, so there we are. Oh, well, that's silver. Okay, I have trouble distinguishing gray and silver. I guess this is gray. Maybe I'll keep it as silver. Okay. There we go. Okay. Now, suppose we could run this and it won't look a one whit of difference. Like visually, when I run it, I won't see anything different here. I mean, like in the main display, it'll just look like a bunch of circles. How if we wanted those circles to be colored by their state? How do we do that? Okay, I'm hearing some great ideas, and we do something with their oval, right? Okay, we click it to dynamic. That's darn right. And we could actually put in logic here that would do exactly that. We could say if they're in the never smoker state, use this color. Just like before, remember we said if they're female, use yellow. Remember that? And otherwise use gray. We could do that here, but it would get kind of messy because we have 3 states instead of 2. Get kind of messy. So I'm going to show you another way, and I'm going to expand your repertoire. I'm going to introduce you to something powerful, but sometimes scary. Okay. It'll be, though, a friend if we use it in tamed ways. Okay. We tame its power with discipline. Okay. So we're going to go to palette and we're going to drag in from here, the agent palette, we're going to drag in a variable. Okay. It's something called a variable. You have not seen variables before. And yet they're useful quantities. Okay. It's going to be a variable. And in contrast to a parameter's job in life is to assume a value and stick to that value by and large. I'm actually glossing over some things, but by and large, that's what you do with parameters. They assume a fixed value. It's a fixed assumption. A variable changes over time. I'm going to call this variable. How did I do it? I notice I added it to person, and I'm going to call it color. Now, there may be a fight that breaks out in this room now. You can, we won't enforce, although we lied, we currently live under the reign of the Queen of Canada. We won't enforce British customs on you. But I'll call it color for making sure my students learn the Queen's English. You can name it as you see fit, okay? And as you'll see, we all eventually have to acknowledge the dominion of the hegemony of the US in just a few minutes. But we're going to call it color. And what's its type going to be? It's not even going to be a few minutes. It's going to be a few seconds. What are its type going to be? Is it a Boolean, an integer? Is it a double? Is it a person? Oh, yes. And look how that's spelled. Okay. Okay. Now we're really in trouble. That's right. That's right. So color, ladies and gentlemen, it's going to be a color. That's what this variable represents. It holds a color, spelled in the manner dictated by Oracle Corporation. Okay. So it's going to be color, and we're going to make its initial color. We'll make it black. It's a good idea to make it a color that you're not expecting to see. So if you see this, you'll know, wait, I've forgotten something. I screwed up because I would have expected to be green, red, or gray. And it was actually still black, you notice too. So often we give it an initial value, which is kind of not supposed to have, okay? So it's black. And we're going to set the color based on what state it's in. So guess what? I'm going to expand your repertoire. Ladies and gentlemen, states, keep track of the state the person is in, given. But more than that, a state, when you come into it or leave it, you can do useful things. You can undertake useful action. And notice, associated with the state is a thing called an entry action. Okay. So that's the things to be done when you enter this state. Okay. And the entry action here can be a bit of Java code. Okay. So what are we gonna do when we enter the state? Anyone gonna guess? We have this here color. And guess what? That's going to denote the color of this person. We haven't made it act that way quite yet, but how are we going to make its color indicate when it's in a certain state? What are we going to do at the entry action of that state? Yeah, what are we going to do to that color then? We're going to assign a color to it. We're going to make it the color we want it to be. What color should it be here? Green is right. But it turns out it's called lime. I don't know why, but to me it looks. But notice it says lime. See that? Maybe that's the British Navy again coming for you. Okay, so this is color equals lime. Okay, now you'll notice a rude entry into your existence, and I'm not referring to the British Navy impressing. I'm talking about. I put a semicolon. We're saying, make my color lime, make me lime. And that's kind of the Canadian like beating up style. But this is saying, make my color lime, okay? And this is a command. This is different from something we've seen thus far. For everything we've seen thus far, we're determining a value. It's like we're calculating value. We're giving a formula for a value. It's what's called, in computer lingo, it's called an expression. But it's a formula to calculate the value. That's everything we've been doing till then. When I determine what my color was based on whether I'm male or female, or when I drew my value from distribution, that was all getting a value. This is actually doing something. Set my value to line. Boom. And it's doing it, okay? And boom, and like that, it will be done, okay? So we're setting it to line, okay? And guess what we're going to do, ladies and gentlemen? You might want to copy this. By the way, you can leave out the O or the U, and we won't punish you. And what will we do here? Anyone? Yeah, we'll set it to red. And it is indeed called red, not crimson or something. And here we'll set it to what? Silver, I guess. Okay, that's great. So now we're setting our color according to this, but there's one more thing we have to do. Can anyone tell me? Can anyone riddle me what? Okay, not a bad idea, but we'll, rather than changing anything on exit, we'll just let it go to whatever stays next, and we'll assign the color next. You don't have to do it. It's a good thought, but we don't have to. But there's something we haven't done yet. We ran this model, what would we see? Yeah, black ovals. Ladies and gentlemen, this is full of sounding because we haven't pitched off what? No, I set the, oh, yes, it will be white oval. White, you're right. You're correct. Larissa is correct. I stand corrected. As is the nature of things, the student ends up replacing the teacher. So it's actually still white. We haven't changed this. So what do we need to change this to for the fill color? Guess what we're going to change it to? What do you yearn to change it to? Okay, well, what do you at least think it might be? Okay, it's a variable. And what variable is it? Okay, and how do I, well, I won't ask you how to spell it. Okay. Look, I'll trade you, like, I bet a lot of people in the US would trade like color with a U for getting rid of a certain past president. Okay, but you can like send them to none of it or something, but yeah, anyway, okay, here we go. So there we go. We're in good shape. Let's try running this thing. And let's do this. And we're going to see something that at once is encouraging and perplexing. What's going on? They're all the same. They're blinking and kind of heinous synchrony. Reminds me of the fireflies I saw in the river in Malaysia one time, blinking all together in synchrony. It was very impressive. This is perhaps less impressive, but it's thoughtful nonetheless. What's going on here? Anyone? Yeah, and is their state changing? So an action is taking place, but what's missing? Remember, we said actions need to be accompanied by what? Rules. And what is the rule here for going from never smoker to current smoker? Yeah, it's in 1 year they will go. That's a pretty grim view of life, isn't it? Like that the infant, after the first year of infancy, it starts smoking. So let's change this first of all. Let's give this a name. It's kind of a good practice to give these names and show names. So I'm going to call this initiation. So that's smoking initiation. And let's give it a, instead of making it a timeout, let's make it a hazard rate if we could. Now, by the way, we can take this a lot further. We can make it an age-specific hazard rate very easily. And if there were demand, I'd be glad to do that. But I'm going to set it to be a rate, and I'm going to set it to, something like 0.02 per year, 2% chance per year. That they will go, if they are never smokers still, that they will go to current smokers. Okay, and let's do something. And now let's run it here. Let's try that. What do you think you'll see now? If I run this now, what will you see? Anyone? Some will stay green. Will the ones that have turned red, will they still be blinking on to gray and off? Will they still be going back and forth, gray and red? Okay, will they be going back and forth in synchrony with all the others? Yeah, it takes a bit of thinking, right? But the answer is probably not, because the timing with which they came in was different. And they leave relative to that. So watch this. Look at that. Looks a little bit more like the fireflies. but indeed, well spoken. Yeah, this is what we see, right? And they're not in synchrony because they came into the current smoker state at different times. And after that, they're just going back and forth. But of course, we could do a similar thing for the others, couldn't we? Shall we not? Okay, shall we? So let's change from current smoker. So ladies and gentlemen, it's really a sad fact that a lot of people who are current smokers, they try to quit and often they fall back. And I'll come back to this point, but I'm going to say cessation, I'll call this one. That's the one, by the way, when you rename it, you can drag it around and label that transition. So I'll call this cessation. And I will make this, instead of a timeout, I'll make it a rate. And we'll make it actually a rate of 2 times per year. Now you may say, what does that mean? It means on average, someone will try to quit twice a year. Okay, is what that means. So it's a hazard rate. It can be greater than 1. It's not a probability. It's a hazard rate. It's a chance being a time. So it means on average they'll quit twice per year, and then we'll have a relapse rate here, which is, we'll call it relapse. Relapse. There we go. There we go. And we'll say show name. Boom. And we'll drag it into place. And we will call it rate. And this will be a relapse rate of 4 times per year. So it's a heinous thing. But the truth is, it's very duration dependent, and we'll come back to that. Let's try this though. Okay. Maybe this is overly pessimistic. Maybe I'll make it 3 times per year. You can choose your parameters as you see fit, and you can run this, and what you will find is, we can get individuals staying, and quitting. Some remain smoking for longer, but a lot are quitting instead of quickly falling back, etc. Okay. Okay. So, ladies and gentlemen, what we have here is a model with a simple representation of smoking. People can initiate smoking, can cease and to relapse. I'd like to add, there's many things we could do to refine this model, and I'd be glad to take this much further if people are interested tomorrow. But there's a few basics that I want to convey. Number one, we could make them experience different levels of heart risk in terms of heart disease based on their smoking status. So the idea would be that in a current smoking state, maybe they're damaging their heart while engaged in this because of the ingestion of the volatiles in the tobacco smoke. Never smokers have lower rates in former smokers compared to current smokers. So if I wanted to represent heart disease in the presence of whether a person had heart disease or not, dichotomously, meaning they either have it or they don't, how would I do that? Suppose I want to represent the process of developing heart disease or having heart disease, whether or not they have it and the development of that. How could I do that in a simple way? I could add a what? I can add a variable, that's possible, I could do it with a variable, but there's even an easier construct. If part of their state was now whether or not they have heart disease, and if it evolved over time, what might I create for it? What's a way in any logic, and for that matter in repass, in which we encode their state and evolution between different states. It's a state chart. Yeah, I could have a little simple state chart. Okay, so let's do that here. Okay, so we're going to add in another state chart, and this is going to be a heart disease state chart. Okay, heart disease. Okay, and I'm going to add in a state here, which is healthy heart. I like to name them with capital letters to indicate at a glance what sort of thing we're dealing with. And so if it's lowercase, it's a transition. If it's uppercase, I know it's a state. Okay. Healthy heart, and I want to call this heart disease. You could start to imagine how we might have mortality risk too, right? We can get to that. Okay, and we'll have a transition between them. Okay, and unfortunately, for the sake of the model, we're making a one-way transition. And so I will call this developing heart disease. Okay, right. Excellent. Okay. And it will be a rate transition. Okay. And by default, it will be 0.01 per year. About a 1% chance per year of developing heart disease. Okay. So now we have two processes governing an individual. Let's make sure the model builds, and let's try running it. So build the model. Boom. Who needs TA help? Who seeks TA help here? The TA's stalwart, stand on guard for thee. Okay, or at least they sit on guard. So who would like TA help? Okay, nobody. I'm standing on guard. Okay, so let's run this thing. Okay, so if we run this, what we will see is something similar to before. But if we drill down to the level of a person, what should we see? Well, notice this is a person who's a never smoker and they have a healthy heart, right? They've not yet initiated smoking. Here's a person who's a former, going back and forth, former and current smoker. And look, they're going to develop heart disease soon. Do you see that? It's counting down, and oh my gosh, they're developed it. You see that? But what's missing here? What's missing? The Surgeon General characterized decades ago about a certain linkage. What is that linkage? Between what and what? Smoking and heart disease. Exactly. So we're going to want to have their presence in these smoking states influence their risk of heart disease. So, as I told you, state charts that are characterized separately have elegance on their side. I mean, you sort of characterize the state of an individual neatly into these different areas. But that's not to say they're solitudes. And in this case, they most certainly are not. There's an interaction between them. A person who's a current smoker can do grievous damage to their heart. How might we capture that? How, ladies and gentlemen, might we capture the fact that while someone's in a never smoking state, their risk of developing heart disease is low, and when they're in a current smoker state, it's high, and then when they're in a former smoker state, it goes back low. How could we communicate to this thing, what that rate of risk is extending from their smoking status, the rate of risk, the hazard rate for developing heart disease? How might we communicate that? What might we do that we've already done for visual purposes? Okay, and yes, an entry action with begins with a V, and there's no U in it. Variable. It's a variable. It's a variable. Yeah. It's a variable. We could use a variable to communicate it. Just like we communicated from this state chart up to this oval. Make your color this. We could use a variable to communicate the level of risk being exerted. Do you understand that? Do you appreciate that? Okay. Let me make sure the online people are. I see my chat window has become hidden again. Okay. So looks like nothing. Does anyone want to ask any questions about where we are thus far, though? Yes, question. Yes, we can say this. Yeah, and I'd be glad to, after I complete this thought, I'd be glad to engage with you to do exactly something like that. There's also one or two other ways we could take it, and I'll describe it. Okay. So yes, we can draw from a distribution, and importantly, we could have that distribution be by person. In other words, we could have on a per person basis. You know, they have a higher chance of developing heart disease because of other risk factors. Maybe it's, you know, factors associated with BMI or family history or something. In other cases, though, we could just draw it, meaning like, in this particular instance, someone is more likely to fall back, but it's not a characteristic of them. It's just the circumstance. They're more likely to be able to quit or whatever. So we could do that in a couple of ways. But let's first complete the thought with this development of risk. So I'm going to drag in a variable. Exactly that was said. So I'm going to drag in a variable. In this one, we won't have a debate about the Queen's English. And you don't have to worry about promising loyalty to the Queen. So here we will set this to be, so this is going to be heart disease hazard. Okay, I hope you'll forgive me for that. And initially it will be, well, what was it initially? We had it to be what, 0.01 per year. So I'm going to set it to 0.01. Okay, so it'll be a per year. Really, I should say annual heart disease hazard, but I'm afraid you'll get sick of me. It's a question of which day of the week that occurs. Okay, so maybe this should be called annual heart disease hazard, but I'll let you fill in the gaps. Okay, so this is the heart disease hazard, and what are we going to do to make it different based on different states they're in? I heard the key idea just a few minutes ago. What are we going to do? This is a variable, and what can we do with that? What did we do with the other variable? Good, we changed it in the entry action. Could we change this variable for a heart disease rate hazard in the entry action? Yeah, we can. Yeah, we can. Yes, we can. So ladies and gentlemen, in the never smoker state, we're going to assign the heart disease hazard to be something really small. Maybe we'll make it 0.005, a half of 1% per year. Okay. And by the way, you might want to copy that. Now, I'm going to show you another trick, because these long names, you may wonder, like, why my students spend more than a day in my lab before running out screaming. And I think that'll be a good question, but you could start typing its name, and you'll find that the names of the variables aren't bad, because once you start typing, you can press a key and it will fill it out for you. Okay, it'll actually say, okay, do you mean heart disease hazard? Is that what you mean? Or do you mean one of these other things? I'm going to say heart disease hazard equals this. Now, what magic key did I press to get that list? What did I have to do to press that list? I started typing the name and I pressed on these computers Control Space. And then I went down and I selected the one with the arrow keys and I pressed enter. But Wade can tell us in a stentorian voice the appropriate key to press on a Mac. On Mac, it's Option Space. Option Space. Okay. So, ladies and gentlemen, we just assigned this to thank you, Wade. Control Space on Windows and Option Space on Mac. So we just signed it for never smoker. That's saying that while they're in this state, the chance of developing heart disease is very low. While in a current smoking state, it's an order of magnitude higher. So here we're going to say heart, and I'm going to go down and pick that. And oops, heart disease hazard. I don't know what heart. There we go. Disease hazard. And we're going to set it to be 0.05. It's going to be actually higher than that. I'm going to set it to be 0.06. Yeah. Okay. Okay. Sorry, I'll make it 0.5. Yeah, sorry. And then this one, I'll set it to be another low value. Heart disease, heart disease hazard. We'll assume there's some kind of residual damage, and I'm going to make it 0.02. We can actually find statistics on this, probability for former smokers of developing heart disease versus current versus never from survival analysis studies, etc. Okay, so I just assigned to that variable. Do people understand that basic idea? Before, I assigned to a variable for color so that when they entered the state, their color would be green. When they entered this state, their color would be red. Now we're just using the same basic idiom to assign to this variable that says the heart disease hazard. But what's the final thing we have to do? Because right now, ladies and gentlemen, this is full of sound and fury. It signifies nothing. What do we still have to do to make it actually the heart disease hazard? We still have to do what? Yeah, exactly. We have to connect the rate. So this rate, instead of just being 0.01, what will it now be? Heart disease hazard. You said it first. That goes exactly right. And we'll build, and it's one happy camper. Okay, so now their chance of developing heart disease depends on their smoking status. While they are a current smoker, it will accelerate the hazard rate by which they develop heart disease. They have a higher chance per year by far of developing heart disease. When they quit, it will lower it until they fall back, when it will be higher again. Do you appreciate that? Okay, now you may be excused for saying, well, okay, what's the big constant here? Well, obviously this is a little toy example. We could do something far richer, but the idea still is maintained. And the bigger these state charts are, the more and more messy it will be to try to tangle them all into a single state chart. It requires never smokers to have all the stages of heart disease and current smokers to have all the stages of heart disease, which is really what you end up doing in aggregate models when you stratify by both. Having an aggregate model where you have both smoking status on the one hand and heart disease on the other is getting pretty messy in an aggregate model. You have to have progression along each one, and you have a model that's stratified by both, and it gets really quite ugly. But here it's actually quite elegant, and you could imagine adding in other habits, maybe BMI level, or whether they're normal weight, overweight, or obese, for example, or you could add in other aspects of behavioral habits and layer them on quite nicely in terms of the risk factors. So let's run this. So I built it. It was a happy camper. And I'm going to run it now, if I may. Here we go. So we're going to show this, and I will go and take a look at this, and we'll see, for example, there's a never smoker. They have a very low rate of heart disease. Notice they're not going to be developing this for 157 years, right? And they're not going to be initiating for a long, long time either. But let's go up to a person. Okay, so this person, what was it? There was one of these people who I saw. Here we are, person one. Oh gosh, look at this. They still have a healthy heart, but oh my gosh, they're switching back and forth, and they're getting awfully close to developing heart disease when they're staying a current smoker. What's saving them is they're quitting quickly, but it's just a matter of time before they stay a current smoker long enough, and they're going to come back. Now, if you're interested in this sort of stuff, your mind may be racing in terms of what we could represent. Maybe what we need to represent is cumulative damage that's been done. Maybe we want to represent number of pack years they've smoked cumulatively, even if they've stopped smoking now. We may want to capture the fact that they, have smoked a great deal and capture that in their heart disease risk. Those things are readily done. We could also, as was asked earlier, have a distribution of possible values. Now they've run out of luck. They've developed heart disease. They stayed smoking long enough to damage it. And we have versions of this model provided to you where they are accumulating the number of years they've stayed smoking, or where when they quit smoking, their probability of relapse drops the longer, on a per year basis, drops the longer and longer they stay quit. So if they could just stay quit for 4 months, 5 months, 6 months, on a per month basis, the chance of falling back into smoking is so much less than that first month of having quit. That first month, they're dealing with withdrawal symptoms from nicotine, et cetera, quite horrendous. But 6 months out, a year out, it's a lot better if they've only survived to that point. They've managed to survive. So this is a situation where we can capture those sorts of effects. Yeah, question. Yeah.
Current model possible for someone to reach former smoker and remain there, or do they have to at some point relapse?
It's a good question. It's a probabilistic thing. They tend to relapse right now very, very quickly. So if we look at it, their relapsing is very troublingly high. It's 3 times per year. So the chance they'll last even for a year is actually quite small. It might be 20% or something. They even last for a year. And this is what I was saying, that in fact, empirically, if you look at former smokers, it is true that the large majority fall back into smoking. However, if they can stay for a year, their chance of falling back in the next year is much lower than it was in the first year of quitting. And that's something which is provided in one of the models we provided you on smoking. Okay, it's exactly that we have their chance of relapse on a per month basis drops strongly based on how long they've spent since smoking. So if they spend longer and longer, their chance of relapsing on a per month basis goes down until they can stay former smoker for very long periods. And that's readily common. Yeah. Now, just a few of these things, though. So, we could take this a couple ways, and I want to take a vote for where we go next. One way we could take this would be, I could divide people up. So some people start as never smokers, some start as current, some as former. Initial statement. A second thing we could do would be we could put in mortality from heart disease, so that someone has a high risk of mortality now from heart disease, in which case they'll disappear from the model. Or we can do the distribution thing and basically have different people have, say, a different risk of initiation for smoking, or a different risk of developing. And probably doing it with initiation for smoking is the easiest one, since the other one is calculated. How many people people would like to see how to get people to start in a different state? Anyone? Well, we'll see it, but anyway, in the next day or so, but I'd be glad to do it now, okay? So one vote for that. How about, how many people would like to see, mortality capture? Okay, got 1, 2. How about online? It's 3, okay. Online, I'm looking for anyone voting. Sorry. Okay. And finally, how many people would like to see the distribution, drawing something from a distribution for the chance? Okay, 1. Okay, it sounds like the biggest interest right now is in mortality. So I'm going to put in place some mortality and let's just see where we're out there. Okay. Does anyone want this saved and distributed to people right now? You got it. You got it. Thanks for letting me know, and we'll get it out to people. I try to do this so that people at any point can pick up the model that we're building and continue on with it, even if you've encountered dysfunction. Okay, here we go, and it's up there. Okay, under models built in class. Okay, so with your leave, I will add in mortality. What we're going to do is we're going to call that version 2. So I'm going to save this as version 2 so we don't overwrite version 1. Okay. So, ladies and gentlemen, what we're going to do is introduce a new element of your vocabulary. It's going to be the Death Star, the final state. Okay, and this is going to represent death. Okay, and we are going to add a transition from heart disease into death, which is going to be called mortality from heart disease. There we go. And there we go. And it is going to be a timeout. No, it's going to be a rate transition. Okay. And I'll make it 0.05 per year. Okay. So on average, they'll survive with heart disease. Maybe I'll make it a bit higher than that. Maybe I'll make it 0.06. So it's about 16 years before, 16, 17 years before they pass away on average. Okay. So the key thing is that what happens when they pass away here, when they get into this state. And this is where I need to introduce a new element for you. I'm going to delete this person from the population, so they disappear. The question was asked earlier online. How easy is it to capture, no, actually, and maybe when Michael asked it, how easy is it to capture open populations where death can occur? It's either Sungju or Michael, can't remember. And the answer was easy. So let's do this, okay? Now, I'm going to need to explain to you something. So we're going to remove this person from the population. Who are we going to remove from the population? All the person who's dying. It goes without saying. Okay, where is the population living in this model? Can anyone tell me? Where does the population live? It lives in Maine. It doesn't live in this person. The person is just a member of that population. The population itself is living in Maine. They're a member of that population. If we want to tell the population, remove this person, we have to tell it in Maine. Hey, remove me. Okay, so that's exactly what we'll do. In order to do that, I'm going to tell Maine, hey, Maine, remove me. There we go. Maine dot remove population. By the way, where does this population? That's the name of the population. If we called it pop, it would have been remove pop. If we had called it Saskatoon, we would have said remove Saskatoon. Okay, and who does it remove? It removes me. And how do I say me in any logic? Not self. Don't worry, self is only when they're being created. It's this. Remove. That's how they say, like me. It's this. I'm. That's what. Yeah, I don't know what comes out. You say remove me. This is how you say me in English. I know you said self before, but self is when the agent isn't yet created. Believe me, once the agent's around, you always say this. In fact, I've been hiding this. This is everywhere. And I could have put it in lots of places, but I didn't want to bother you with it. But this is a place where it can't be avoided. Okay, so remove this, and it's a command. It's a do this, do it, and it's therefore a semicolon. It's an imperative. It's a vocative. It says do it. Okay, there we go. So, ladies and gentlemen, build it. Oh, the guard is, if there are certain conditions where this, where only, this can fire only under certain conditions. Maybe there's a pregnancy transition where it requires the agent to be female, for example, in which case you'd have a guard to make sure the agent is female. And if the agent is a female, it won't consider that transition. Yeah. Or maybe it has something to do with the agent's, current immigration status or whatever, that they're only then qualified to go down a certain path if they meet this criteria. It's basically testing the criteria that has to be passed for it to go down that way. Okay, yeah. It's actually quite elegant in some places. Okay, so we've removed this. Can we run this now? Oh, there's a question, Bjorn. You can indeed. You can indeed. It's for the most part, these state charts, with the exception of the final state, the state charts have to stay independent, but multiple state charts can have the same final state. In fact, when they reach this final state from any place that can lead to it, here it will destroy the agent, right? If the agent is removed. Yeah, that's exactly right. Yeah. Oh, wait, looks like I put that in the dying transition. I really should have put it. I mean, I could put in either since there's only one entry point, but generally I like to put it at the state chart. Yes, Louisa. Well, it's going to go when this transition fires. It would have gone off, but just in case we want to connect any other states to this, it's kind of nicer if it's here, since it lends a certain finality to it, as it were, a certain unity to it, that all of them will lead to this removal of the agent. So let's, and what should we see different this time? Anyone? Yeah, the population is going to decrease. And if we, run it fast and empires rise and fall. I know it's kind of a grim view. But there we go. Now, mind you, we could have, of course, had, and this is per Vyom's question, we could have had mortality transitions, for people who remain never smokers. They have a chance of mortality too. And it doesn't require someone to develop heart disease. They could die from other causes. And so you could end up having, lengths from different states accordingly. But I hope you recognize that this actually offers a certain, certain clarity of sort of modeling here associated with it. So I'm going to save this. Would anyone like me to post this model? Okay, you got it. So do, and I will post version 2. There we go. Now there were some questions about, these other components, putting them in different initial states, quite easily done. And it would introduce conditional transitions. And I think we'll start that. So here I will do this. So in order to distribute them initially in these different states, what I would do is from my palette, I first of all, I lift this entry off and I put in a branch transition here. There we go. There we go. Okay. Great. And okay. And then we're going to have them be distributed in these three possible states. So we're going to go and add transitions here. And at first we will have our aesthetics insulted by these transitions, even more so than by the instructor. So we've just added these transitions, and now I'm going to engage in sort of aesthetic remediation as best I can as an engineer. And so I'm going to sort of clean these up like that, and I'm going to double click. Hey, come on, get back here. And we'll sort of stretch this out here. And this doesn't look hideous, but you know, neither would it be in the Met. So that's not horrendous. Okay. So I've added this kind of entry conditional, and I'm actually abusing it right now because you notice all three of these are dotted, and actually only one should be dotted, the default one. And so if you click on never smoker, this is marked as default, but so are the others. And those others are mere pretenders for the throne. Those are not in fact the defaults. So I'm going to change these to be conditional. There we go. Conditional, ladies and gentlemen. They're going to be conditioned. And under what conditions will they be invoked? Well, we will invoke them in certain circumstances. And I'm tempted to do this kind of more beautifully. I'm tempted to do it beautifully. It'll take a wee bit more mechanism, but it will be general. I'm pulled in by the beauty of the idea. I could right now make this conditional on a certain fraction of cases, but I feel awkward about it because we need it to split three ways, not just two. If we're just two ways, I could flip a coin and pick which way do they go. With three ways, it gets a wee bit messier. So I'm tempted to have them done in a better way in terms of their initial state. Can I do it? It'll take about 5 minutes. Can I do it? What's that?
I allow.
Okay, thank you. I'm gonna do it right. With your leave, I'm gonna do it right. Or do you really want to see it done wrong? Okay, so ladies and gentlemen, I'm gonna do this thing right. I'm gonna demonstrate it to you. This is how you do it done right. Okay. So here from the palette, I'm going to add in an initial state, initial smoking state. This is a parameter. We're going to pass it in. We're going to say, you start in this state. Okay, that's what we're going to do. And you don't have to use that voice, but it can help you. Okay, so now what is this initial smoking state going to be? Well, you're getting ahead of yourself. So we're going to go back to projects. So what did I do? I added in a parameter and I didn't bother saying what it is yet. That will come in just a moment. We're going to go back to main. We're going to go down main and we're going to right click here and we're going to say new option list. What else? Where did we use an option list before? Can anyone tell me? Yes. So we used it for male and female. Do you remember that? We specified possibilities. That's what we're going to use it for. We're going to specify possibilities for what? The reason for that. But what are we going to specify possibilities for? That's exactly it. Okay. So here we go. Okay. So got me all fired up here. Okay. So I'm going to call this initial smoking state. Okay. And I'm I'm gonna say initial never smoker, initial, by the way, you notice I'm dodging something here. What am I dodging? Anyone? I don't want to name this the same name. I don't want to call it just never smoker, because that's called over there, it's called never smoker. The state is already called that. So I'm actually giving it a different name to sidestep that issue. Former smoker. Do you see that? Those are three possibilities. They can start as a never smoker, as a current smoker, or as a former smoker. Fair enough? Okay. Now, because I'm doing it this way, I don't have to do it this way, but it's recommended by elegance and by functionality at once. Okay. So I'm going to say finish. What did I do here? For those who didn't follow that, I right-clicked on this. I said new option list. Boom. And I called it initial smoking state, and I did initial never, initial current, initial former. It lives, this option list lives in the model as a whole. And now, ladies and gentlemen, we are poised. And where are we poised? We are poised on the edge of greatness. Because the situation is laid out for us. We can just proceed with beauty and functionality at once. Let me show you how. Okay. So what I'm going to do is I'm going to add in here to this model a custom distribution. This is going to link back to a question we had from Maggie. So Maggie had asked, could we associate distributions with things? She was asking about those transitions, but I'm going to show with a distribution here. I'm going to add a custom distribution, and it's going to be called initial smoking state distribution. I know it lacks in imagination, but it makes up for it in clarity. Okay. And guess what this is going to be a distribution over? Over what type? A continuous variable, discrete variable, or options? Anyone? Options is right. And what option list? The initial smoking state. So this is going to be a distribution over possible values of smoking. We're going to be able to say never smokers are 90% of, or are 60% of the population. Current smokers are 30% and former smokers are 10, or whatever it is. Okay, so now we can say data here. And guess what? We can fill these in. So never smokers will be, I'll say 60%. I'll say current smokers are 20%. And I'll say former smokers are 20% as well. Do you see that? Okay, so now we have a custom distribution based on the value, based on these possible values of the initial state. Oh my God. Oh, well. Indeed. Out black spot. Okay, so Okay, great. So, ladies and gentlemen, we stand on the cusp of greatness. Okay, so let's finish this, okay? Let's finish the thought. So we have this distribution. We have a parameter in person that specifies what's their initial smoking state. What is that parameter going to be? What type is it going to be? Set up an option list. What type of is the initial smoking state going to be? Remember, we once had a parameter that was their sex. Remember that previous model? This parameter, that was an option list. Do we have an option list in this model? What is that option list? In the initial smoking state. So the type of initial smoking state is initial smoking state with a capital I, not to be forgotten, not to be ignored. Okay, and its default value will be initial never mumble smoker. By the way, I did control space and it was happy. Okay, so that's what its initial value is going to be. But now it needs to have action. It needs to have bite to it. It needs to affect the model or affect the model. So how's it gonna affect the model? Can anyone say? What's it gonna affect? The initial smoking state is gonna affect what in the model? It's gonna affect where they're routed here. So if someone is under what condition will someone go to the never smokers, current smoker state when they come in? Anyone? If they are what? If initial smoking state is what? Will they go here? Yeah. So this will be under what condition? Initial smoking state double equals. Because we're saying, is it equal? That's the condition under which they will go this way. Is it equal to initial smoking, initial current smoker? Boom, just like that. Do you see that? That's the condition under which they'll go this way. What is the condition under which they will go this way? Anyone? What's the condition under which someone will go this way? If their initial smoking state is what? Initial former smoker. So they will go this way if their initial smoking state, they're going to be told, you start here, sir. And they're going to say, yes, ma'am. Where do I go? And they say, you go to the former smoker state. And he's going to say, yes, ma'am. Just like that. Okay. And so here, the initial smoking state is initial former smoker. You got that? So they're going to be routed here if they're told to be an initial former smoker. They're going to be routed here if they're told to be an initial current smoker. And otherwise, they will be a never smoker and they'll just fall into this as their defaults. That's what this thing is. It's the default. Okay, we're almost done. Greatness is about to be achieved. We just have one more thing to do to complete the thought. One more thing to achieve the objective of surviving the day. What is that? We still have to divide the population up to these things. And what is it that tells the value of this parameter to each and every person? Where in the model is the place that says you have this initial smoking state, you have that one? Remember before we did it with age? Where was the place in the model that said you have this age, you have that age, you have that age? And actually drew it from the distribution. Where is it? Population indeed. You speak well. So let's go back to Maine, and the population lives in Maine, and there we go. There we go. Their initial smoker state. By the way, why does it say initial smoker, never smoker? That's the default value, we told it. If no one tells you, assume it's this. But no, where do we want to get this from? Remember, this is the rule it uses for each person. For each person in the population, it will run this little bit. It will run this formula. Right now, the formula is simple, but what formula? Yeah, we draw it from the distribution. You got it. You got it. Okay, so we're going to draw it from initial smoking state distribution. And all we do is we call it and we say, give us a value. That's all it is, ladies and gentlemen. We say, give us one of your values. Just like this. I'll put it up on the big screen. There we go. That's all we do. We call it and we say, give me one of your values. Give me one of your values. Give me another one of your values. For each person in the population, give me a value. Give me a value. Give me a value. And that value that it returns will tell where is this person going to go when they start in the smoking steps. You got that? And when it tells it that, to the person, that's going to pass it in for their initial smoking state. And here, in their initial smoking state, here, it's going to be whatever value was told to it. If they're told to be a current smoker, they're going to go just like that. If they're told to be a former smoker, they're going to go like that. And if they're told to be a never smoker, they're just going to fall through. Do you get the gist of it? Okay. So the population, just like before, the population was drawing values for their age and assigning it for their parameter for each person in turn got an age. Here, each person in turn is gonna get told what's your initial smoking state. And when they come into this state chart, they're gonna be routed accordingly to their appropriate home. That is how you do this with elegance and power. Okay, now let's run it, if we may. Because greatness, ladies and gentlemen, has been achieved even in our midst. Okay, due to your request. Okay, yeah. So let's run this model and let us sit in collective awe. Okay, you'll notice that when we started running it, and I will pause it and restart it, and I will start it slow. And you will see people started. How did this differ from the old model? People started what? How did this differ at its very inception from the old model? Yeah, before they all started in the same state. They all start as never smokers. Now they start in a veritable panoply of states. By the way, I'll show you a trick, if I may. May I show you a trick? Okay, thank you. So if I run this, but I don't actually start it. Okay, I'm gonna go back. I'm not actually gonna start it. I pressed stop and I went back. One thing you can do is go over to this panel. And if you come up here, you can do this step. And by pressing step once here, you will actually be able to go and sort of see the model in its initial state. Okay, it allows us to sort of step through at a slow level. And that's actually very, very useful in terms of sort of seeing what its initial state is. I'm not illustrating this well, but I'll go back and start this. So I'm going to say step, and then I'm going to press this button of the little house to show it. How did I do that again? I'm going to stop. I'm going to say step, and this shows it its initial state just as it's starting out for anything that's happened. And how do I see it in front of me? I press the house. There we go. It stands before me. This, ladies and gentlemen, is the initial state. This is the initial state achieved by your request. And I would note that these requests have at once illustrated the three requests upon which people voted. Number one, illustration of how to route people to their initial states. Number two, drawing from distribution. Number three, having deaths occurring from the population. So we now have an open population. Ladies and gentlemen, greatness has been achieved because of your request. So thank you. Okay. So what have we learned? We've learned how to build up a little model. We've learned how to achieve heterogeneity with economy of mechanism. We've learned how to use parameters at the agent level and at the level of main to both communicate, to both encode assumptions and communicate them in the level of main from the scenario to main, and for our agents from the population or the point of creation to the agent. We've seen populations. We've seen heterogeneity separating different agents. We've seen how we could declaratively visualize the different colors. We've seen how we could add statistics in this very afternoon. And you, through your very hand, have added dynamics into these models. Dynamics not only in terms of one process, but two processes. And finally, in response to your prescient questions, we have added in an open population with mortality, where people can unfortunately die. We have added in a distribution of people among initial states, and we've shown how you can use distributions to elegantly draw values that can be chosen from a custom distribution and provide it through parameters to particular individuals. And all done so in a way without writing a lot of horrendous code. There has been code there. They're not to deny it. We encountered code containing no less than the Queen's English. We used it, however, artfully to communicate among multiple state charts. So these weren't solitudes, but instead each state, one state chart influenced the other. And we can make it reciprocal if we wanted to do so. And to do that, we achieve that with these variables. And we nicely decomposed a complex situation into two subcomponents, one for one condition and one for another condition, by dividing them up into state charts. But ladies and gentlemen, something is missing. Ladies and gentlemen, we're just at the start of our journey. You've actually learned some of the most core mechanisms, but tomorrow, great things await. Tomorrow, we're going to see how agents can interact with their environment. We're going to see how agents can interact with each other. Because right now, these persons, these men and women are but islands. They're not influencing. They're evolving, but they are doing so in an atomistic way. And tomorrow, we will break down that so that they communicate with each other, the couples within the model. We'll also build on these strengths, but see how we can use networks to link up individuals and how those networks can serve as conduits of influence from one person to another. And we'll build up what we've learned in terms of statistics being calculated over the population to help us keep track of the current situation of the model. But perhaps most importantly, ladies and gentlemen, tomorrow morning, we're going to talk about how to use these tools we've built up to characterize complex situations in ways that are at once flexible but restrained. Perhaps you've gotten a sense by adding the right mechanisms in, by using these palettes of great fullness in different ways. There's all sorts of things we can add into a model like this. You know, this is not a matter of just adding in stocks and flows. This is a matter of adding in a much larger vocabulary. And tomorrow morning, we're going to be discussing this phenomenon of model conceptualization. We're going to try to get you going, those in the incubator, with some exercises for you. And some exercises to get you thinking about the scope of your model, what it might look like by distinguishing between different types of ways you might represent factors in your model. And we'll go through some exercises together for the incubator that will set you on your way in your first meetings with the TA tomorrow. Okay? So if you haven't done so and you're in the incubator, please fill in that spreadsheet. I pointed you to it this morning. I will send mail to Maya to point her to it after class here. But within the participant resources, there's a spreadsheet called Project Ideas, and right now it lies empty. We really need entries in there so we can assign TAs for the project. So I wrote an email to you, those in the room, about this, and we need you to fill in the first 4 columns of this so that we can fill in the others. We'll be providing you some references to example models that might be of interest. We'll be assigning TAs. We'll ask you to meet at a certain location so I can find you. And there's some other. So if you could start filling those in, that would be great. And I'll work to assign you to appropriate fields. Okay. So I think we've accomplished a lot today. I want to thank you for your patience. I want to thank you for your good questions and your accommodations. And I'll look forward to interacting with you tomorrow. Okay. And with those comments, I will rest. Thank you very much. And for online users, I'm looking forward to seeing you tomorrow. Yes, 8:30 tomorrow, same time as today. And we much look forward to joining you then. Thanks so much.